Okay, so you're waiting for how do you call it? Isabel and Jotia to join. Today we'll try and see if we can complete the standard form. When we are done with the standard form, we'll look at vectors. Okay, so did I say standard form? Sorry. Enlargement and similarities, and then when we are done with it, we'll look at vectors. Okay, so let's wait for Isabella Cole. For Isabella and Georgina to join us quickly so that we can start. But whilst they join us, I'm just going to draw something on the board, and then you're going to try your hands on it. So okay, Chotia, you're welcome. Isabel too is joining, so I think Isabel has joined now. Chotia, don't worry, the other videos I've recorded them, so I would upload them so that you can get access to it. I don't know what happened that you couldn't join us the rest of the days. But what we've done so far basically is we completed the standard form, and then I think I went over the mapping. And when we're done, we started with enlargement. Okay, so today we are just going to talk about the enlargement again. I'm going to explain the whole process again so that we'll finalize it. And then when we are done with that, we'll just quickly move to vectors. So we'll start vectors hopefully today. I'm hoping that we should be able to do all this in the next 40 minutes so that we can all go. Okay, so this is what I have on the board. But before we try this, let me just put some figures here. I have 3 centimeters here, and then I have 9 centimeters here. And then this place is 2 centimeters. And then they are saying we should find this. Okay, so let me quickly, this will be our example 1 for today, but let's do a quick recap. So a quick recap, if I have something like this. You have A, B, C, and this place is B1 and then maybe C1, or you can make it A, B, C, D, E. Okay, if you have something like this, basically what will happen is that we and then we have 2 centimeters here, and then so why are you so excited?
Please, I'm talking to my sister.
Okay. Okay, so once we have this, and then we have maybe 1.5 here, and then we have X here. Fantastic. So what will happen is that we want to find the value of X. Okay. Now, before we find the value of X, on Tuesday, we said that before we find the value of X, there's something called scale factor. Okay. There's something called scale factor, and using that scale factor is going to help us find the value of X. How do we find that scale factor? And we discovered a formula which says that what length of image over length, what have I written? This is length. Ignore that. Over length of what? Objects. Okay? Length. Okay? So don't worry about it. So length of image over length of what? Objects. That is how we find the scale factor. Why do we need a scale factor? When we get a scale factor, we'll know what was multiplied with a smaller version of a side of the shape to give us the larger version of the side of that particular shape. And we also said that if you want to find a scale factor and you're using a particular length, you should use its corresponding enlarged side. So when we look at it closely, when we look at this, our example on the board closely, we have this side and this side. They are the corresponding sides. So in terms of the scale factor, the size that we are going to be using, we'll end up using the AC, which will be our object. Okay, we say that the smaller portion of it is always the object, and then the bigger portion of it is our what? Image. Okay, so it means that from here to this side is going to be our object, and then from this side to this side is going to be our what? Image. So those will be the length. We can't say that we are going to be using 1.5 and then we'll use what? A to C1. They are not corresponding length. If you are using 1.5, then we have to use the X because those ones are the corresponding sides of the object and the image. So quickly, we can establish that our objects, the length of our object is going to be what? 2. But how about the length of our image? The length of our image is not 4, but it is what? 2 plus 4, because we are comparing, or we want the whole length from A to C. So 2 plus 4, you just write it there quickly, and then you get 6 over 2. Then now you can break down to get 3, and that's going to give us 3 as our scale factor. Once we have 3 as our scale factor, it basically means that any length at all that has been given to us in terms of the object, we can use the scale factor to find the enlarged portion of that particular side of the shape. Okay, so if I have 1.5 here and they are saying I should find X, X has basically been scaled by 3. What does it mean to be scaled by 3? It means that it is a multiple. It has been multiplied 3 times in order to get what? The X. 1.5 has been multiplied 3 times to get what? The X. Okay? So basically, it means that in order to find the X, X is basically going to be the scale factor times what? 1.5. And we actually derive that whole thing from the formula. If I should simplify this formula for you, let's see how we can find X. So we are actually using 1.5 centimeters and X centimeters to replace the length of image and then to replace the length of object, okay? So we can say scale factor equal X, which is the length of what? Image, over 1.5, which is what? The length of objects. And we've actually done our calculation to get our scale factor. So we'll just quickly replace the scale factor with what? 3 equals X over 1.5. Okay. I'm trying to explain how I got the X equals Fx times what? 1.5. So now we'll just send this 3.5 to 1.5 to the 3 to multiply. And we all know that when we do that multiplication, it's going to be 4.5 centimeters. So because of the scale factor, we can now confidently say that the value of X is what? 4.5 centimeters. It is the same process we are going to use to determine the X in this particular shape, the number 1. Okay, so we'll take number 2, then I'll take questions from you, concerns from you concerning this topic. Then if there's no any other thing we need to do and we have time, we'll quickly move to the vectors, okay? So basically that is how you find scale factor, and then you find an unknown enlarged side. Sometimes too, what they can do is that they can give you the enlarged size, but they won't give you the object size, okay? So for instance, they can decide to give you the X side, and then they'll actually put a variable here for you to find the object side. So we'll look at an example like that before we move to another topic. The term is short, so we will have to work fast in order to cover all that we need to do before exams, so that we can also start our revision for exams as soon as possible. Okay, so let me clean this quickly. My other software that helps me to clean is on the other computer. I've stopped using it for some time now, so this is how I'll be cleaning, very slow. Okay. So now let's solve the number 1. Now solving the number 1, remember you need to understand a rule in order to help you find the scale factor. And that rule says the corresponding side. How do you find the corresponding side? Normally, if you get a shape like this, the corresponding side, sometimes if the length is diagonal, then it means its corresponding side will be in line with the diagonal side of it. Okay, so for this one, because the 3 is here, oh no, what did I just do? I think I have to redraw the whole thing again. So let me go back and then draw it. So this was the drawing. And we had A, B, C, and then we had B1 and then A1. And this place was 3 centimeters and this place was 9 centimeters. So as I was saying, we need to know the corresponding side. Is the corresponding side that's going to help us find the scale factor. And this place was actually 2 centimeters and this place was X centimeters. So how do we find the scale factor? We find the scale factor by actually knowing the length of image over length of objects. Okay, so that's how we know the scale factor. How do we get the values to fix in, or how do we know which one is length of image and which one is length of object? We pick the one that has been given to us that has the object length and then the image length. So looking on the screen, we can confidently say that A to C is our length of objects, and then A to A1 will be our length of image. Okay, the trick is that they will not state some of the shapes, even the simple shapes. An example will be the one that we just did. They will not state the full length of what's the image, but they will break it so that you have to do some form of addition. Okay, sometimes what they do, the reason why they do that is students are in a hurry and they'll just end up writing the 9 centimeters as the length of what image. So let's quickly use what we have to find the scale factor. And we stated that the scale factor is length of image over length of object. Therefore, if you want something, the easiest replacement will be 3 for the length of what object, which is 3. And then length of image is actually from the A towards the A1. Okay, so we'll fix that. That'll be 3 plus what? No. Sorry. So with this particular shape, the rule is actually different. Let me call someone. Who can tell me why the rule will be different for this particular shape? Denzel, why do you think the rule will be different from this particular shape?
Please, is it because it's slanted?
Yes, so it's one, because it's slanted. Let's look at where C is for both of them. Regina, where would the length of image start from for this particular shape? Can you hear me? Okay, but you can't talk, or is your mic not working? Okay, it's working now.
I'm not sure.
You're not sure. So if you have a shape like this, let me. The reason why I retracted back basically is if we have a shape like this, okay, and we have A, B, C. The reason why the length of image will be from A to C is that if we take the enlarged image, it's going to be this thing, this whole thing. Okay, it's going to be, okay, it's going to be the whole triangle. So if you want to calculate the length of image, we would have to start from A and end at C. But comparing it to this particular shape, the object is actually separated from the image. This is the object. This whole thing is the object. And then this is the image. Okay. So if you want to play we want to use the concept of the first image, which is this image, to solve this, we might get it wrong. It basically means that for this particular shape, this one, the length of object is from A to C. And then the length of image for this particular one, because it's twisted and then the enlarged portion is separated from it, the length of image is going to be from C to A1. Okay, so this time around, we are not going to do any form of addition. So that the type of shape you are using for your enlargement actually is relevant, is important. It's different from this. If I have something like this, and I have A, B, C, D, E, F, G. Okay, so for this particular one, if they write here 2 as my length of object, and then they write here maybe 4, okay, and then they say that I should use this to find the scale factor, I would have to do an addition because my length of object, or my object, this is my object, okay, so it would be what? A to C. But my length of image is this whole thing. This is my image, this whole, the bigger box, which starts from A and ends at G. So I'd have to do some form of addition with what? 2 and 4. But this first shape has been twisted, which means that the enlarged shape is different from what? The object shape. The object shape is different from what? The image shape. Okay, so that's how come we are starting from C to A1. I hope we are okay. Isabel, are you understand this?
Yes.
Fantastic. So we will solve this, but let me just draw a similar thing on the board and let's find out if we are going to be using, if we are going to be doing an addition, or we are doing addition to find the length of image, or it's just going to be a simple one. So let's look at something like this. Then we have here 2 centimeters, and we have here 4 centimeters. We have A, B, C, D, E. So Chotia, what do you think? Will we do addition in order to get our length of image, or it's just going to be it's going to be separated?
Please, I don't think you're going to add.
You don't think you are going to add? Okay, Denzel, how about you?
We are not going to add.
You are not going to add. Okay, fantastic. Was Isabel, how about you? Are we adding?
I don't really understand the concept of this one.
The concept. Okay, so what I was trying to say is that if I have this shape, you realize that this shape, the smaller portion that has been enlarged, let me use a different marker, maybe it's because the smaller shape that has been enlarged to get this bigger shape is fused together. So we can say that the smaller shape, which is this one, is using the same length to get the bigger shape. So if I have here to be 2, this is A, C, and maybe D. I have here to be 2, and this place is 4, okay? To find the length of image, it is going to be AC. To find the length of object, is going to be what? AC. But to find the length of image is going to be A to D. Do you get it? So when you look at it closely, A to D is on the same line. So it means that I would have to use the 2 and the 4, because from here to the D is actually AC plus what? CD. So I'd have to do some form of addition. But when we look at this closely, this is the corresponding what? Sides that I'm supposed to use. And this is the image. Sorry, this is the object for the enlargement. And then this is the image for the enlargement. you realize that they are separated, okay? So if I want to find the length of object, it's actually A to what? C. Good. It's actually A to C. Now with A to C, that is my what? Object. But when it comes to the image is starting from where? The shape of the image is not starting from A. Do you get it? It's starting from C. So C to what? E. So this time around, we can't say that we are going to be adding 2 to 4 in order to get the length of image. But it's going, because it has been a separated shape, it is twisted, and the enlarged shape is different from the, how do you call it, the object shape. We are not supposed to do addition. Isabel, are you okay?
Yes.
Okay, fantastic. So with this one, we are not doing addition, but something like this, which is something like this, or the triangle form of it, we have to do some form of addition. Now, sometimes what they'll do is that the shapes might not even be joined together. They can draw something like this, and then they'll draw a bigger one. So with that one too, you are not supposed to do any form of addition because the object shape is different from the image shape. So with that one, you just have to pick their corresponding sides. And the corresponding side, if I have here to be 1.5 and I have here to be 2 centimeters, and this place, it is only 4 centimeters that has been labeled. I can't go and choose the 1.5 and then choose the 4. I have to choose a look-alike of the side. Okay, so if it is 2, we know 2 is the base length. We have to choose the base length for what? The enlarged shape also. So that is how we use, or that's how we can discover the values that we are supposed to fix in the formula for the scale factor in order to get a scale factor and then find the rest of the object. So I'm going to go back and then, yes, I'm going to go back. I'll clean the ones I've drawn down here, and then we're going to continue with the solution quickly. So now looking at it, we've all agreed that what we have A to C to be our length of object. So that would be what, 3. And we have C to A1 to be our length of image. That would be what, 9. So let's quickly find the scale factor. Finding the scale factor, this would cancel this to give us 3. So it means our scale factor is what, 3. Now that we have the scale factor, we just have to fix it into the formula. Okay, and then the formula we are using the same formula. We now know the scale factor. So wherever we see SF, we'll put 3 there. We have been given 2, which is the what? Length of what? Object. So we'll fix that there, 2. And then they're asking us to find the length of image, which will be what? X. So all we need to do is to just find the value of X. So this 2 divided will go to the side to give us what? To be multiplying. So it becomes 3 times what? 2. And then X is actually 6. So 6 centimeters. So using the scale factor 3, it means if this side is 2 centimeters, this side should be 6 centimeters. Okay. If I should, let me see, if I put 5 here, I can easily find this side, basically because they are the corresponding side. Okay. And how can I find the side? Because now I know the scale factor. Scale factor basically means you are doing multiplication. Anytime you forget this, all you need to do is to pick the scale factor in the formula like what I've done here, and then pick the objects that has been given to you, and then you use it to find the length of image. At times, what they'll do is that they'll actually give you the length of image, and then they'll say you should find the length of object. So let's look at that also. Let's say if they give us this place to be 12 centimeters, and then they give us M. So now you realize that this is actually, the smaller portion is the object. So length of object is M, and then length of image, which is the bigger side of it, is what? 12. And then they are saying that we should find m. All we need to do is to state our formula. We know our formula already. So length of image, I'll just cut it short, image over object. Now we're just fixing what we have. We know our scale factor to be 3. So the scale factor, once you find it, it applies to all the sides of what? The image and then the object. So you don't have to recalculate for a scale factor for different sides of what? The shape. Once you find the scale factor using any of the corresponding lengths, that is it. So the scale factor is 3, our image is 12, and then we are finding m. So we'll quickly do that. Now the m is multiplying. We can't find m when it is dividing. Sorry, the m is dividing. We can't find m when it's dividing. So we'll take it to this side to go and multiply. So it becomes 3m equals 12. And then once it's 3m equals 12, we can actually divide both sides by 3. And then now m will be equal to 12 over 3. And then when we break it down, we'll get 4. So it means that we have 4 here. So if you have your enlarged side to be 12 per the scale factor, your object side should be 4. Okay, so let's use the other diagram that I drew to explain the reason why we don't add in all of them to actually solve another concept. Okay, so let's use this one. So I'm going to label this one nicely. Let me just clean whatever I've written there. Okay, so, and then you see the trick is that to make this topic is actually easy, but what makes it stressful is sometimes they bring a lot of decimals in it, and then they bring this kinds of shape. And because some teachers, when they are teaching, will just teach the addition aspect of it, students will end up adding. There are certain cases that you need to add, as I've explained, and there are certain cases that you don't need to add. You just have to pick them like that. Okay, so let's see if I put 10 here and then I put 30 here. Okay. Okay, let me make it 25 so that we can get some form of decimal to work with. So 25. Okay. So 10 centimeters, 25 centimeters, and then we've been given F, and this place is 45 centimeters. They're saying we should find the scale factor. So the question is, find the scale factor and the value of F. So that's the question. So the first thing is we quickly write our formula down. And our formula is scale factor Fx, SF equals length of image. Remember, it's always image at the top, just like the way we have gradients. It's not X that is starting, it is Y that is starting. It is always image at the top before the object. So we have something like this. Why image at the top? Because the scale factor can never be a proper fraction. What do I mean by proper fraction? The numerator of the scale, if the scale factor should be a fraction, the numerator can never be smaller than the denominator. That's for scale factor. It's just like calculating. It's the opposite of probability. Probability, probability can never go beyond 1. So if I have 3 over 2, this is more than 1. Okay, so this can never be a probability. It's just the opposite of what? Scale factor. Scale factor cannot be below what? 1, or it cannot be less than 1, because once you get a proper fraction, proper fractions are always less than 1. So once you get a proper fraction, it can be a scale factor. That's why you have the object at the top and then you have the image at the top and then the object below it. So let's keep that in mind. So that anytime you are confused and going to write the object at the top, would remember that this is the opposite of how probability works. Okay, so now that we've stated our formula, we'll quickly go to our diagram and we'll find out whether we are supposed to do some form of addition or not. And with this particular one, we are not supposed to do any form of addition because the object is actually separated from the image. So they are both will have different lengths. So this one, the object length is 10. And then the image length is what? 25. We are not supposed to do any form of addition because they are separated. Look at the object. The object here makes a perfect what? Triangle. Complete. It's not fused with the image. The image also makes a perfect what? Triangle using the 25. It's not fused with what? The object. That is how come we are not doing any form of addition. So once we have this, when you have 25 over 10, all you need to do is to flip the dots. So our answer is going to be 5. Okay. So our scale factor is what? 2.5. Remember, scale factor, we don't put any units there because it's a scale. There's no measurements like centimeters or anything. But it's when you are finding the corresponding length of size that you fix in your units at as the final answer. So once we've discovered our scale factor, we can quickly fix that value and then the 45 into the question in order to, how do you call it? In order to, we'll fix it into the question in order to get the value of what? F. Okay. So I've just been prompted that we have 8 minutes more. So maybe we would have to rejoin. If not, then we'll start the vectors next week. So let's find out. Let's just finish this one and see if we want to rejoin or we'll start the vectors next week. So having this basically, we know our scale factor. So it will be what? 2.5 equals, this is what the length of image. The 45 is the length of image. So 45 over F. The F is what? The length of object. So now we'll take the F to this side. And then it becomes 2.5 times what? F equals 45. Okay. And then we'll divide both sides by 2.5. Okay. And then we'll cancel. Then we have F equals 45 over what? 45, not 4.5. Let me clean that decimal. So 0.5. So we assume that the decimal point for the 45 is outside. So when I flip again to get 25, we'll put 0 here. Okay, the decimal point will flip here, so there will be 0. So the original thing now becomes 450 divided by 25. And with this one, we can use 5 to cancel. So 5 will go here, 5. 5 will go into 45, how many times? 9, so that's 90. 5 will go here, 1. 5 will go into 90, how many times? How many times will 5 go into 90?
18.
18, fantastic. So it means F is equal to what? 18. Let me write it this way. So it becomes F equals what? 18. Please take note of how I played with the decimal so that you don't worry yourself to go and do any form of long division. I had 45 over 2.5. All I need to do is to get rid of the decimal point in the denominator. And how do I do that? We know that the 45 has a decimal point this way. So I'll flip it out. And once I flip it, the down part out, I have to do the same thing to the top. Once you have a K, there's a 0 that you can fix in there. So it becomes 150 over 25. Then you can quickly do your breakdown in order to get your answer. So the answer is what? 18. Now, remember the F is actually a length. So you have to fix in your unit, which will be centimeters. And then voila, you are done. So basically, this is the concept for enlargements and similarities. Most of the questions that will be given to you might not be a diagram question, but might be written out. So what I'm going to do is that today I'll actually send some that are actually in word form, okay, to you as assignments. Just play around with it. You normally see A1 representing the object, and then you see A representing the object and A1 representing the image. So they will say P is what? Maybe 5 centimeters, and then P1, Q1 is what? 10 centimeters. When it happens like that, it basically means that this is what? The length of what? The image, and then this is the length of object. And then they will just say, use this to find the scale factor. So once you have something like this, you just play around with it. So you should expect work from me. Should we continue with the vectors, or we should call it a day and do the vectors next week? Chotia. Oh, feel free.
It depends on my other classmates.
So that if you have any assignments, you can quickly go and do them. Do you have any deadlines to meet?
Is today?
Yes, any
Maybe
subjects
No.
outstanding?
Yes, ICT. Just on Saturday.
ICT.
ICT.
Mm,
we have ICT, we
You
have
should be
science.
tracking the assignments so that you don't miss any assignments. Okay.
ICT is the only one I have right now because I've done everything.
Okay. Denzel, do you have ICT? Chotia, do you have ICT?
Yes,
Yes.
please. We have ICT, we have
Yes.
science, we have French.
So please be tracking the
Yeah,
assignment.
that's French.
What teacher, you see, what Google Classroom does is that the time you submit the assignment is recorded there. If the teacher states 6 and you submit a 6-1, Google Classroom will tell the teacher that submitted late. We always get that notification, submitted late. Do you get it? So what the teachers are marking now, I'm sure that so far I have been able to mark most of your assignments. But what teachers are going
But
to do is that
even
late,
if it's just 1 minute late,
yes,
does it put the time there?
yeah, they put the time there and then they write in the
Okay.
late. So please be careful, be submitting us because I created the Google Classroom for lower primary and GHS. And so it means that I have access to all those classes and Form 1, Form 2. You realize that most students, I go keep getting notifications submitted late at this time, then they write the time and then they write the subjects and then the assignments. So I'll keep on getting notifications that submitted late, submitted late. If I go to my phone right now, I'm sure, see, Ni Abiashi, week 3, classwork exercise 3, electrical energy, submitted late. And at 9, so teachers will know whether you submit the assignments late or not. So it doesn't matter whether maybe a teacher has not yet marked or does not mark the assignment. When they are ready to mark, they'll get all those days, all those data, and then they are going to work with all those data. So please let's actually look at it carefully. And then please, when you go to Google Classroom, kindly go to the People tab, okay? When you go to the People tab, look for your name and tap on it. When you tap on it, it will show you the percentage of work that you have done, okay? It records all work that has been assigned to you, okay? So yesterday when I checked, for someone like, I think, Piasa has done 33 point something percent of all the work that has been given to him so far. And when I checked Elompodo has even done 91 point something percent of all the work that has been given to him so far. And then the ones
Where do you find this?
that's actually written there. Yes, Shotia.
Mr. Lugosi, please, why is it that, for example, BDT, the other two subjects assign their work to everyone?
They assign their, you see, they don't know how to separate the students. Separate the students. You have to go and uncheck all those people who don't do BDT. And I think that's tedious. So what they do is that they just assign it to everyone. So when you see visual and you don't do visual, then you don't even attempt it at all. But at the end of the day, that's also going to create that percentage thing on your dashboard. So what I'll do is that I'll talk to Mr. Yanni about it and then we'll see how best we can resolve that. So please be tracking your assignments. It's very important. And then just submit it. Just do it and submit it. Now it's like you have school, and that's how come the pressure keeps coming from left and right. Even though you do only 3 or 4 subjects a day, it's basically the timetable has been programmed to keep you busy from 9 in the morning till 5 because of assignments. So just keep it as such and then do it so that after 5 you have your freedom to do whatever you want to do. But don't intertwine it with your normal social activities. It will disturb you. Remember, this is Trinity 10.
Mr. Lugosi,
Yes.
is there a way to remove the subjects that you don't do from the list? Because sometimes it confuses me when I'm doing the work.
Which one? The BDT, the BDT.
Yes, and then the tree.
Okay, so I'll try as much as possible to see if I can go to those teachers' dashboard and remove the students. I doubt if it will be possible because they are supposed to do that. So yeah, I'll talk to Mr. Yanni about it and then we'll see how best we can. So Chi, you still get a notification for?
Yes, and work.
Okay, sure. So I'll find out. I'll talk to Mr. Yanni about it and then we'll look at how best we can structure that.
Okay.
What we were supposed to do is that every subject is supposed to have his or her own class. But we realized that it would be a lot of classes and students will lose track of which class they need to go into at what time. That's how come the subjects are actually, in terms of topics, we've actually replaced them with subjects. Do you get it? So let's see how best we can manage that. Okay, so the time is up. The thing will go up very soon.
Oh, Hillary said she will join in September.
September. Okay, that's fine. So all the best. I'll send you work. So next week we'll do the vectors. Okay. Don't forget Saturday we have tutorials on YouTube at 1. Okay.
Okay.
And please, when you go to Telegram and tell your people. Some of them have been calling to say that they were struggling to submit. So the new submission time is at 9. So anyone who has not submitted, I'm giving them up to 9 o'clock to submit. Okay. After
For the math class work.
for the math homework. So after 9 o'clock,
Homework.
anyone who submits, I'll deduct math. So can you tell them?
Okay.
So those who are struggling to submit, tell them to keep on trying. They shouldn't send the work to me, because if they send the work to me, I'll not be able to record it. Okay. Okay. So that is it.
Okay.